Hello everybody, I will start my today another live coding session. So today I solve this question. Minimum window substring. Given two strings s and t of ranks m and n respectively, returns the minimum window substring of s such that every character in t, including duplicate, is included in the window. If there is no such substring, returns the empty string. The test cases will be generated such that the answer is unique. Okay, so let me start with the clarification of my understanding. In this question, I will be given two strings, s and t. And I will return the minimum window substring of s, which will be string, that substring or empty string. Okay, so this is the interface. For the constraint, I'm wondering the ranks of s, ranks of t, and what kind of characters composes s and t. I take a look. Yep, and I can find that both of ranks of s and ranks of t is one or larger. Yep, and also s and t consist of uppercase and lowercase English letters. So this means that there are 52 characters. So I can think of this as a constant number. Okay. So that's what I wanted to clarify. So let me take a look at the examples. So let's say S is A, B, B, C, 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 B, B, D, and T should be A, B, B, C, C, D. Yep. Let me change the order a little bit. Like this. In this case, I should return true. Oh, no. I should return the minimum window substring. Sorry. That's good. Yeah, example. So let's think of this. And let's say I have something like this. So in this case, I should return ABBC. No. AX, BX, BXC. And another example is like, let's say I don't have B here. So I have only one B. So because BB is not included, there is only one B in S, so I return an empty string. Okay, so this is it. So let me think of the approach I can use. So what I'm thinking right now is creating the counter for this T. Then check every possible substring of S and see if the substring contains all the characters from T. And if it is true, update the returned string. And then I return string. Yep. In this way. But roughly saying, this takes at least because in line 24, I check every substring. So assuming there are S characters in the S, this takes S squared time. And I have to check if, the chosen substring contains all the characters from T. So it also takes S. And also I have to create the counter. So it should take OT time. So basically it takes S cubed plus T at least. time complexity. So let me optimize this. So I will create the counter. In this case, A1, B2, and C1. Yeah. And I have the string S. And I have to include all of these. Yeah, I can think of this. So let's say I use the sliding window, and I think on the of the right index. So when right index is this one, A, I don't have enough characters yet in the window. I have to keep going. So when I am here, AX, still not enough. So I continue, keep moving, the left pointer. And the point here, now this has all the characters. Yeah. So let me change a little bit. Let's say this has BB here. Yeah. In this case, when I move the right pointer to here, let me say, nothing happens, but it has one extra B. Then the right pointer is moved until this A. What happens is that it has, excuse me, extra A and B. So now this can be shrinked under here. So this is shorter. So I can return this one in the end. Yeah. So basically I can use the sliding window. But the problem is if I keep track of the characters as the counter for the current window, comparing that counter and the counter of T takes more time. In the worst case, it takes O of S or T. I mean, I have to check this one. So O of S, assuming that the window is full length. In that case, I have to check each, character is included in the T. Sorry, no. I have to check each character from T and the number of characters, that character in the counter of current window. It could take all of T time. So in total, this takes S times T time. But I'm thinking if I can optimize this more. Yeah. So can I check the inclusion of window characters counters in T counters in the constant time? So window has something like this. A1, B3, C1, X3. So I basically keep track of this and this. And I have to check what is not enough yet. Which character is not enough yet? Yeah, like this. The first three, all the characters are missing. So A and B and C is missing. And every time I add a new character, and let's say A becomes 2, I take a look at I compare this A with this. Sorry, I mean, because this A is included in the missing character, I compare A2 and A2, A1, and I find out that, sorry, let's say this is 2. In this case, at this moment, this A in S, number A in the S becomes completely the same as number A in the T. So in this moment, I can delete this. But let's say this A is popped out from the window and becomes like this. At this moment, this A is one smaller than the number of A in the T. So this A should be reverted, added. Yep. So adding or removing the character when adding or removing the character from the window, I check if it is a missing character. Yeah. And yeah, that's something I can do. So let me explain this while I'm implementing this. But in this way, I don't have to, iterate, or I should say linear scan the counter, so it becomes always time. And for space complexity, I need S plus T because I need the counter for both string S and both string T. I mean, window of in the string S, but the window can be at max length S. So it all S plus T. Okay, so now let me get started with the implementation. So sorry, I need the counter. Window chars. So every time here, right is added. So this one should be added to the window counter. And I will check. So for now, I'm missing all the characters. So here, I add this. And if this one is in the missing chars, and number of this is now exactly equal to the number of that in S chars, I delete this from missing chars. Okay. So now I've moved the right window. And from here, I, move the left pointer as much as possible because I'm looking for the minimum window. So as long as there isn't any missing chars, maybe I can shrink. So I do left plus equal 1, but I have to take care. So if I do this, maybe it doesn't meet the condition. In that time, in that case, I can't move the left pointer. So how can I do? So strs so what matters is the popped out char s right is in wait, it should be teachers. Yeah, this is in teachers, and if I decrement the count, or I should say, if this character is contained in W chars, the same number as those in S chars. So in that case, I break, because in this case, I can't move the left character. If I move the left character, what happens is, number of S left in the window is smaller than S chars. Yeah, number in the S chars. Sorry, teachers. Yeah. And I move the left pointer and decrement this in the window chars. No, I have to decrement first and then move. Okay, so this is it. And here, if there isn't any missing characters, I can update the returned substring. But if I have I don't initiate the substring here, because in Python, initiating the substring takes the linear time. So here current ranks is right minus left plus 1. This. And also I will keep track mini ranks and mini low, mini high. This is something I update when I find the shorter one. Okay, let me say I will already continue here. And here, this and this. And in the end, I return mini low or mini high in this way. Okay, this is it. So that makes sense. Let me quickly test my code. I will go with very simple case like A, C, B, and A, B. Yeah. So teachers. Let's go with this. Yeah. Teachers is now C1 only. Window char is now firstly empty. And missing chars is C only. Okay. So mini ranks is max infinity. Mini low, mini high is non-none. Okay. Left begins with 0. So left is now here. And in line 66, right moves from here. And when right is 0, S right A is in the missing chairs no. So I go to line 73. Ranks the missing chairs is not 0. I go to line 79 and I continue. And come back to line 67. Right is now index 1. Window chairs S right plus equal 1. So now this has C1. Okay. And S right is in missing chairs, yes. And window chairs C, the count is 1, is equal to the T chairs C, count 1, yes. The missing chairs dot removes S right. So this one is removed. Okay, and I go to line 73. Length of missing chairs is 0. So I go to line 74. And S left in teachers A is not in teachers. So I go to line 75 and break and come to line 79. And now ranks of the missing chairs is 0. I go to line 82. Current ranks is right minus left plus 1, which is, oh, sorry. I should have moved. Wait. So in line 74, S left is A, is in teachers. No, this is not in teachers actually. I can go to line 76 and W chairs A decremented. Why when the chair doesn't have A1? Yeah, I think it should have A1 first in line 68. But probably I forgot it. But here, where chairs is left decremented, so this becomes 0. And then in line 77, left plus equal 1. So it goes here. Yep. So now ranks as a missing chairs is 0. And by the way, this is true. So I go to line 74. S left, C is in teachers. Yes. And word chairs C count is 1 is equal to that number in teachers, 1. This is true. So I go to line 75 and break. And now length of the missing chairs is 0. So, yep. I go to line 82 and now current ranks is 1. Current ranks is smaller than mini rank, which is infinity now. So mini ranks is 1. And this now becomes 1, 1. Okay. Good. And I come back to line 67 and right is now here. I will go quickly. But basically, window chair here, B1 is added. And in line 70, this B is not included in the missing chairs, so I don't have to take care of this. So I go to line 73. Because rank of the missing chairs is now 0, I go into the while loop. And then line 74, S left. Yep. I cannot pop out this left C for the same reason as before. So I break and go to line 79. Rank of missing chairs is 0, so I go to line 82. And right and left is 2 and 1. So now current ranks is 2, which is not smaller than mini ranks 1. So that's the end. And I go out of the for loop and return S index mini low to mini high, which is 1, 1, so C. Okay, so completely as expected. So I passed this test case. Okay, so I could cover all the lines actually with this easy example. Probably I should have checked some more complicated cases, like let's say I have a yeah, like he has duplicated characters. Yeah, there's something like that. And actually I have to check the case when, you know, I should return false. Yeah, but I don't do that for now. Okay, that being said, let me submit. So, okay. One thing I forgot to do is if mini ranks is still mass infinity, I should return -1, no, empty string. Otherwise, I return this. But seems like this is none. Okay, let's check it. Good. Okay, accepted. Great. Okay, so let me quickly wrap up. So today I solved the question, minimum window substring. In this question, I'm given two string s and t, and I will return the minimum window substring of s, which contains all the characters from t, including duplicates. So for this question, I use the sliding window. And basically, I use the left pointer, and I shrink the window by moving the right pointer as much as possible. Yeah. But when I do that, when I shrink it, I have to check I can keep shrinking. Yeah. And that inclusion check, I did it in the constant time. That's the kind of optimization I made in this sliding window approach. And for that, I kept track of the counter of characters in the given string t and also in the current window. And also I created the hash set for missing chairs. Yeah. So that's basically it. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.